on initializing fields, I'll still use the circle class example from the previous session. You could have your fields declared inside your class like this. So private int origin1, private int origin2, public static int number of circles, or you can decide to initialize them like this, where you're setting all of them to 0. Please note, it is not a requirement to put all your fields at the top of the class, but it's preferred. It's like it's the convention, but it's not a requirement. Moving on, this makes a lot of sense, this kind of initialization, when it's just for a single sentence, when it's just for a single value, like you're seeing a 0 in each case here. However, sometimes you might want to have some logic as part of your initialization. So for the instance variables, because these are instance variables, if you missed the session, please check it out. These are instance variables. This one is a class variable. For the instance variables, it is possible to initialize their logic inside a constructor. So maybe you want to check some errors, have some balances and so on, you put it inside the constructor. So what happens then when you're working with a class variable? For a class variable, you would work with a static initialization block or static initialization blocks. This is where you have a block of code with a keyword static before it, then you put your logic inside there. The static blocks are called in the order in which they appear in your code. So that is part one. And another way to do it is to either create a method, a static method, and then that method could be returning a value of the particular type. Then you can set that returned value in a variable as your initialization. So you can either work with a static block or you can work with a method, initialization method, and then you set the value of that method to a variable. This is good because it's reusable or when you want to reuse. So I'll just go to the IntelliJ and show you what this is, because we've already done constructors. I hope we all know we've already done in a previous session instance variables and how they are an instance or part of an object creation, while the class variables are not. So when I jump to the demo, I'll show us static initialization blocks and how they work. So I'm inside the circle class. Here are our declared variables. Here is our declared class variable. Here are our declared instance variables. And we are focusing on static block. So I want to initialize without working with one sentence. It could be anything really inside the static block. So to show us how this will work, I'll just use a print line statement. Static init block ren. Then I'll run that. So what will happen in my main method, I have this line of code here. My previous session, it's creating object oval from the circle class. I have this line of code that is going to print the value of number of cycles, which I had initialized in this constructor here. This other one will print the number of circles, which I have also initialized in the constructor because I'm creating an object from the constructor. So if I run this, what I will see is this. Number one, static init block ren. Then 1, then 2. So 1 and 2 is from a previous session. Let's focus on this. A static initialization block only runs once. So no matter how many instances you create, it doesn't affect the static init block. Remember, a static variable or a class variable, whichever name you prefer to call it, is not part of the instance, it's part of the class, as we have seen in a previous session. So it only runs once and it runs in the order in which you include it in your code. You can put it anywhere. Let me even put it here between a method. So static without a static init2. If I run this, sorry, if I run this, I expect to see the first static block, the second static block before the initialization in the constructors or before the instances. So here we go. It runs once in the order in which it appears in your code. You can use it to initialize your static variables or your class variables. And then we have the initialization in the constructors will follow in the order in which you create the objects. So that's that. If you want to have some logic of initialization, you work with a static block for your class variables. If you want to have some logic for your instance variables, you can work with the constructor. Now, as an alternative to the static block, you can also just work with a method, which is returning some value after the logic. Then you set that value to a variable of the same type. So for example, in this case, it is int, right? A static variable of the same type. So in this case, it's int. So you should, in that case, create a static method of data type int, have its return value, then you set it there to initialize it. You can also have an initializer block instead for the initialization of the instance variables. So this is where you would have a block of code without the word static, and it will work as an initializer block for instance variables. So I'll go and demonstrate so we can see clearly why we would sometimes prefer to work with an initializer block. What I'll do is I'll just change this to an initializer block, and I'll say initializer block ren. And I'll also change this to initializer block. Let's see the difference. Okay, so if I run this, you will see that before the instance creation, the initializer block runs in order in which they appear. So initializer block ren, initializer block 2, then the creation of the object. Then I have initializer block run again, initializer block 2, then the creation of the object. So what happens is when you're working with an initializer block, the initializer block is bundled as part of your or along with your constructor. So if you would need to have some code that is initialized in every constructor, consider working with the initializer block. It knows to run it with every constructor. So it's best for when you need to share some code between your constructors. Another thing you can also do with instance variables is to initialize your logic using final methods. What you need to know about final methods is they cannot be overridden by a subclass unless you mark it as protected. We talked about access modifiers in the previous session. So if you have an access modifier protected in this final method, then you can see it in a subclass. Otherwise, final methods cannot be overridden in a subclass. It works the same way as this method here, the static method. So you need to have your final method, your logic here, and the return. Then you set the value to some variable that will work as initialization. And like this other method here, you can also reuse it. So to summarize, when you're initializing your variables, you can initialize them to a value like this. This is done and it makes sense for single line initializations. Otherwise, for instance variables, you can initialize your logic in a constructor or in a block, especially if you have a logic that should be applied to more than one constructor and you don't want to have boilerplate code, which is just repeated code. Or you can work with a method that you can reuse elsewhere. Then we have the static block. static initializer block for the class variable or instance static variables. It only runs once, as shown us in a previous demo, or you can work with a static method and set it to a variable. And that is that on initializing your variable. Please make a point of looking through the code. Once again, if you want to understand, it's just the same code. In fact, I'll just append the same code from the previous section so you can practice on your own. I'll work with that code, try and create a few static blocks, try and create a few initializer blocks. In your code, I'll not append a different link. It's just the same link as the previous session before this one. Try and look to understand what's going on here. Like in this case, we're creating an instance, then we are printing the value for our static variable that we had included in our constructor, and here from a previous session. Just have some nice practice with the static blocks and initializer blocks. I hope I've made a point of trying to make us understand how they work and why. See you on the next one.